start going through. Okay.
Hi everyone, we're just waiting for a few more people to join and then we'll get started.
Okay. All right. So let me join. Hey, happy Friday, everyone. We'll just get started with the quick kind of introduction here. And while other people are joining so that we can continue the session. We have like 1 hour and we really want to kind of time box the live demo upgrade as well. So I'll just get started while people are joining. So my name is Gopal. I am a principal DevOps consultant from Adaptavist. I have like 13 plus years of experience in DevOps land. I'm a GitLab certified professional services engineer. And yeah, today's topic is GitLab Zero Downtime Upgrade webinar. So we're going to see the live demo. I have my colleagues, Carl Edwards and Jobin. I would pass it to Carl. They'll be helping with all the kind of Q&A. If you have any kind of questions, please feel free to kind of post those in chat and team will be helping to provide the answers. Though we'll have a separate like 10 minutes for the Q&A as in last as well. But yeah, meanwhile, still, if you have any questions, please feel free to post this in the chat. So I'll pass it to Carl for a quick introduction. Yeah.
Hey, I'm Carl Edwards. I'll just be helping Gopal with Q&A. I just want to reiterate, please keep the questions and answers in the Q&A section rather than in the chat, just so we can have those recorded.
Yep. Thank you, Carl. I'd like to pass it to Jobin for the quick introduction.
Hey folks, my name is Jobin Krivula. I'm the head of solution strategy at Adaptavist. I was very excited to hear about this GitLab solution, so I'm looking forward to seeing it in live action, and hopefully you all will learn something from this. Thank you.
Awesome. Thank you, Jobin, and thank you, Carl. Okay, so yeah, here's today's agenda. We're gonna cover what is GitLab, GitLab reference architecture, various installation methods, GitLab environment toolkit, which is a open source project. I'm gonna talk about that one real quick. The zero downtime upgrade, for which we all are here, and a live demo. So we're gonna upgrade one of the demo site that I have created in AWS, a GitLab instance, and we're gonna perform the upgrade live. So that is the plan. And then the Q&A if you have any questions. But yeah, like I said, please feel free to post any kind of questions in the chat as well, and team will be providing answers to it. So yeah, what is GitLab? All right. So as you all know, most of you may have already worked with GitLab or heard somewhere, maybe in your open source project or at your organization. But yeah, real quick introduction. It is a complete DevSecOps platform that enables all the teams to perform all the tasks in a single project, like from project planning to source code management to monitoring and security. Additionally, it allows all teams to collaborate and build better software. So, why GitLab? It helps to increase software quality and developer efficiency. One other good benefit, I would say, it's a tool that could remove toolchain complexity and manage everything in one UI. You may have used like for project planning, like Jira, Monday, or maybe Asana. For source code management, you may have used like Bitbucket, GitHub, GitLab. For CI/CD, you may have used Jenkins, Argo CD, and various different tools. Similarly, for continuous deployment as well, and when it comes to like monitoring and security. But think about just one single one-stop shop for everything, right? So that way your developers don't have to like switch between the different toolings when it comes. Just one single platform, and they can do everything from your idea, like project planning, to deploying it to production. So that's what GitLab is. So that's why it helps to achieve faster development cycles. And the best benefit is security and governance, which are really critical component of your software delivery lifecycle. They are built in. So, with every your code commit, you will see if there are any vulnerabilities, any kind of things. Also, you can maintain the on the governance side, like compliance management and those kind of things. They are also built in. There's little kind of additional thing around all the flows and what all additional features. I mean, as part of this demo, we're not gonna cover, go over each individual details, but yeah, you probably got the gist what exactly or how GitLab can really benefit to your organization. Yeah,
Hey,
GitLab
Gopal,
reference.
do you
Yeah.
mind if we start presentation mode?
Oh, yeah, sure.
Thank you.
Is this good?
Yep, that's perfect. Thank you.
Okay, awesome. So GitLab reference architecture. So when you are logged into GitLab, this is the recommended architecture from GitLab. So there are various different components which are running in the backend to make your GitLab up and running, right? Some of these components would be optional, but pretty much I'll just go over quickly around each individual component and what's its job and how that is helping for and what's its role when it comes to GitLab, right? So start with the external load balancer. That will be like the front end of your GitLab on which you're actually hitting or accessing your GitLab site. So that is your external load balancer. We'll talk with Git cluster. So Git cluster is basically a GitLab provided and recommended fault tolerance solution for storing your Git repositories. So that's where when you create project and you have Git repositories, that's where those get stored. So those are stored in Git cluster consists of, like, you can have as part of reference recommended architecture to have multi-node and highly available and scalable solution. You would expect like 3 Git nodes at least in your setup. You will have Prophet, which is like the routing and transaction manager for your Git cluster. And this Prophet will have its own database to store information around the Git cluster status. That's how this whole thing consists of the Git cluster, to kind of provide a fault tolerance and highly available solution for your Git repositories. Then comes the GitLab database, which is the basically primary database information that is to store your users, permissions, and issues, and all the metadata around those kind of things are stored in your GitLab database. There will be an optional thing called PG Bouncer that is basically for tracking and managing any kind of reads and writes to your primary database. This is an optional service. If you're using, let's say, any of the managed service like AWS RDS to host your database, then you probably won't, then you don't require PG Bouncer, because in the managed service, that will be taken care with the RDS that you're using. Redis, which is a non-persistent database for your like job information, your incoming jobs queue, and any sort of metadata that gets stored, any kind of non-persistent data that gets stored in Redis cache. You'll have an internal load balancer that is for any kind of communication within the GitLab. For that, you have an internal load balancer. Rails, which is basically a front end of your GitLab. So whenever you're logging into GitLab, you see that UI, that is Rails. So that's a Ruby on Rails application. On the Rails node, you will see you will be having like Puma, which is your application server, Workhorse, a GitLab shell. So any kind of front end request that goes through your UI, through your API, any sort of HTTP or SSH communication, it goes through Rails. Sidekick, which is also one of the component, it is a background job processor for GitLab. So GitLab uses this Sidekick to execute all your asynchronous run tasks, basically to run all the tasks in the backend. Sidekick is the background job processor. Consul and Prometheus, these are advanced kind of things. You'll be using this. Consul will be auto discovery mechanism for your monitoring targets. If you're using, let's say, Prometheus and Grafana for your GitLab whole monitoring system, then Consul is little optional. You can use that to kind of auto discover the targets, and that will send it to Prometheus, and that's how you'll perform the monitoring. Object storage, we'll be having our GitLab site in AWS, so I can talk about like object storage. In this case, we'll be using S3, and that is for like storing any sort of information around your job logs, your artifacts, your uploads, any kind of things. Those get stored to any kind of object storage that goes to the S3. So these are all the various components. And as you could see, like for majority of these components, you'll have like 3 nodes of each except for like database. You have like RDS. If you're using AWS RDS, then you'll probably be using multi-AZ, those kind of things to make it more highly available and kind of thing. But yeah, you can see Rails 3 nodes, Sidekick, and then the Redis. And so this is the real GitLab architecture. And this is the same setup which will be required if you're using more than like 3K architecture. This is the recommended, like when I'm saying 3K architecture, that is for 3,000 user and more, right? So you'll be having some sort of these. I mean, definitely the instance types, I mean, the resources you will provision based on the need. But yeah, this is the highly set up around your GitLab. Okay, we kind of went over all of these GitLab components, but yeah, just a little kind of description, all what exactly each component is doing. So that kind of thing in this slide. GitLab installation methods. So there are various ways with which you could install GitLab. So we're just gonna quickly go over which installation method you're gonna use and when would you choose that one, right? So the most recommended and the first one is Linux package. Previously, this was known as Omnibus GitLab. You may have heard like Omnibus GitLab. So this is an official like Debian and RPM packages. It's a Linux package basically. So you will install as a Linux package, and GitLab and its all dependent components, including Postgres, Redis, and Sidekick, they get installed through it. You'll use this because this is the most mature scaled method. This version is also used by GitLab.com. So GitLab.com, which is the SaaS version of GitLab, if you are using it or if you have come across that one, that is deployed using the same method, Linux package. Helm chart. Helm, which is a package repository manager for your Kubernetes. So this will be a chart for installing a cloud native version of GitLab and its component onto Kubernetes. I mean, you'll use this if you have your infrastructure in Kubernetes and you're familiar with it. But keep in mind, if you have a smaller installation, this may get little expensive because you will have in that redundant fashion, all of these individual components deployed, right? So for the smaller installation, this could be a little expensive. Docker, all of your GitLab packages in a single Docker container, and you'll use this if you're familiar with Docker for the demo purpose or some local kind of thing. You can definitely use a Docker-based installation. Source-based, so GitLab and all of its components which we saw, you can install those from scratch as well. So if none of these previous methods which we just talked about, they're not supported for your platform, then you'll use a source method. Then is there this GitLab environment toolkit, which is a Get. We're just going to go over this one. So this is an open source project that has been developed by the GitLab QA engineering team. And it's basically a set of opinionated Terraform and Ansible scripts. You can use this to deploy a reference architecture onto pretty much all the major cloud providers. It does support AWS, GCP, Azure, on-prem systems, and pretty much all of the setup. So there are certain limitations. I mean, definitely, if you're looking to use Get for your production, you may have to do some additional configurations to make it work in your production environment. But it's really well supported and very well maintained by the GitLab team. So we're going to go over this real quick after this slide. So GitLab operator, yeah, installation and management method that follows the Kubernetes operator platform. And yeah, this can be used to run GitLab in an OpenShift environment. So yeah, these are all the various different installation methods. But yeah, frankly, the major ones which are really used is the Linux package and either the Helm chart. These two, the first two are the most widely or commonly used. And GitLab environment toolkit, which in a way use the Linux package to install, but it does provide like Terraform and Ansible scripts to install GitLab. All right, so GitLab environment toolkit. Yeah, this is the, I'm going to go over this project and like the basic configuration, what all things are required and that kind of thing. But yeah, it's basically, it uses Terraform and Ansible to deploy a GitLab instance. You will define those configurations and you can deploy those to AWS, GCP, Azure, or pretty much anywhere. So when we come in here, I mean, before we go to zero downtime upgrade, I would like to go over the site. So just for this purpose of this webinar and around our main topic, which is the zero downtime upgrade, I have created a GitLab site, which is hosted in AWS. So I use the same GitLab environment toolkit project to deploy a GitLab highly available, scalable site in AWS. So we'll just go over real quick how that architecture or how that setup looks like. These are various kind of configurations. Before we go in here, we can go through this guy. All right. So this is the, I mean, if you just type in GitLab environment toolkit, you'll come to this. This is an open source project, which has been created by GitLab, like I said, and it does provide a configuration which is based in Terraform and Ansible. You could deploy a GitLab site to the respective platform. So I have cloned this project already in my local. And basically, if we just look at, let's say, Terraform, you'll create an environment file. Basically, you'll have your environment folder, and inside that, you will have certain kind of Terraform configs. Definitely, you'll require some sort of Terraform and Ansible and infrastructure as code knowledge to kind of work around this. But as part of this demo, or a major goal is not to look into the GitLab environment toolkit, but we really wanted to have a site which we can use to perform a zero downtime upgrade, how the upgrade looks like with zero downtime. But I'll just go real quick to show how exactly the site was built up, and then we can start on the upgrade. And because of the fact the upgrade will take like 25 to 30 minutes, the way we're going to cover is I'm going to start the upgrade, and then we'll come back to some of our rest of the slides while the upgrade is happening, so that within the same time frame, to respect the time, we can also perform the upgrade and cover the rest of the topic. So real quick, here you could define AMI. This is all based on AWS, frankly. I mean, all of this setup, because I have deployed my GitLab site in AWS. So it'll provide an AMI image that you want to use. You'll have the instance type, which is the resources that will be provisioned for the Gitali component, for Prophet, the number of nodes for every component that you would require, Sidekick, Rails. I have skipped the monitoring and console nodes in this, and also the open search, which is for the like advanced search in GitLab. Those things are additional things. Those are really not required for your GitLab, but yeah, those are really nice to have kind of things. So for this purpose of demo, to keep it simple, we have skipped those things because those are those will come in an advanced topic. But we'll definitely have like Gitali, Prophet, Rails, Sidekick, and also the database as well. So there are two databases, one for the GitLab database and one for the Prophet database that is also getting deployed. And we are also using Redis for the caching mechanism. So if we go into our this guy, the AWS console, you can see I have my instances up and running. So like from the reference architecture, like we saw, these are the, yeah, so these are all the nodes which have been already deployed using Terraform, using the GitLab environment toolkit project. So there are 2 Sidekick nodes, 3 Prophet nodes, 2 Rails node, and 3 Gitali nodes. So this is up and running. If you go to RDS, which is a managed service, managed database service in AWS, if you go to RDS, you will see there are 2 databases as well for this GitLab setup. And if you go to databases and just type in zero downtime. Yeah, these are the 2 databases. First one is GitLab database, and second one is Prophet database, which is getting used. It does have the Route 53, I mean the load balancer as well, on which we'll be accessing our site. So just for this purpose, I mean, this is the site which has been of version 16.2.8, and it has been deployed into AWS. So this is already up and running. The purpose of this webinar and for the demo, the goal that we're going to achieve is we want to go from 16.2 to 16.3, which is the next version in this series. So we're going to start the upgrade. I'll go over the upgrade automation and how exactly that is working in the backend once we start the upgrade. So one thing that I wanted to mention, if you haven't done the GitLab upgrade anytime, like for majority of the applications, the way it works, there is, you cannot go, let's say if you're on version 15, you cannot go to 16 directly. There is a incremental upgrade path that you need to follow, because with every version of upgrade, there are certain database migration tasks. Those need to be performed so that the version is up and running, and before you could jump to the next version. So the compatibility of those database migration tasks has to be performed for that respective version. So in this case, let's say if we just look at this, so I mean, you can use this guide. You'll just type in GitLab upgrade path, and you can come to this site. This is maintained by GitLab, and this is just a site where you can see the current version that you are on, the version that you want to go to, and what would be the upgrade path that would look like. So let's say if you go to 16.1.5, currently assume that our current version is 16.1.5, and the latest version is 16.6.2. So depending upon your community edition, enterprise edition, or the distro like CentOS, Ubuntu, and here you could choose if it's zero downtime or you want to go with without zero downtime. For the purpose of this webinar, we'll be covering the zero downtime. So I'll select this guy and just go. So you can see from going to 16.16 to 16.6, these are the versions that you will have to go to, right? So currently we are on 16.2.8. If you look at this, the site that we're going to use for our current demo, if we look at the version, we are on 16.2.8 version, right? So the purpose, we're going to go from 16.2.8, which is this version, to 16.3.6. So let's just start the upgrade here. And then I'll cover rest of the topic, how that is working and how that has been built. So my automation we're going to use, that is built around the systems manager SSM. So using that, we're going to perform the upgrade from 16.2.8 to the next version, which is 16.3.6. So you're going to come to SSM, come to owned by me, just search for upgrade here. And this is the upgrade automation that has been created. So just execute this automation. And in this case, we're going to use rate control feature because the way, because it is a zero downtime, the upgrade has to be performed on one node of that cluster and before moving to the next. So that way there is no downtime at all. So with rate control, you can define your concurrency and error threshold. That's how you can achieve, okay, if in a cluster there are like 3 nodes, you can still define, okay, it should perform any kind of tasks onto one node before moving to the other. Make sure the tasks are completed on one node before it goes to the next one. So there are certain parameters that I need to provide, cluster namespace, like parameter values. One thing that it needs, a sidekick deploy node. So we're going to pick one node as a deploy node, on which you can pick sidekick or the Rails as well. For the current purpose, the way automation has been built, we need one node of sidekick, which will be used as a deploy node onto which certain of the migration tasks and those kind of things will be performed. So just going to come here. This is one of the, using this interactive instance speaker, I'll just gonna pick GitLab zero downtime sidekick, which is the site and one of the node. You can pick any one. I have 2 nodes. I just picked one, the one that came at the top. You'll provide the version that you want to go to. In this case, we are on 16.2.8, so we can go to 16.3.6, which is the next version. So we're gonna go to 16.3.6. Cluster namespace will be GitLab -zero downtime. Yeah, this is my cluster namespace, as you could see from the naming convention around the stacks, GitLab -zero downtime. And this is not a geo environment, so it will be false. You can define the concurrency and error threshold. I'll keep those default. We don't have to make any changes into that one and just execute. So yeah, this has started the upgrade. So the live demo around the current site that we have. So this is up, and yeah, the expectation is from this version of 16.2.8, we would want to go to 16.3 now. So yeah, we're gonna definitely perform certain tasks to make sure, okay, site is up while the upgrade is happening. So yeah, you can see 16.2.8. Let's just look at the execution task here. So I'm gonna cover all of these things, what exactly it is doing, because now, because this will gonna take like 25 minutes or so, I wanted to really start around the time so that we can have this finished under our webinar window. So, all right. So while that is happening, we can go over what exactly each task is doing and how this has been built and how this can really help to transform the things and really help the operations team, and not just the operations teams, how this can really benefit the organizations to keep up with the GitLab versions while still not getting any sort of downtime at all. So in this case, as you can see, the first step is to stop sidekick on deploy node. If you remember, we just provided one deploy node at the beginning. It needed one thing, so we provided one of the sidekick nodes. We have 2 nodes in our cluster, so it's stopping sidekick on that particular node. So if you look at these logs, this is really cool feature of AWS SSM. You can look at these logs as well, and you can see it has stopped the sidekick here, right, on that particular node. And then the way this whole thing goes is it would perform an upgrade on the Git Alley, which is the Git repository management for the GitLab storage. So in Git Alley, we have 3 nodes, right? So in this setup, it will basically perform the Git Alley upgrade from 16.2.8 to 16.3.6. And because of the fact we used a rate control feature of Systems Manager, you could see it's performing the job on only one node at a time. That is the intent, right? Because in a cluster, there are 3 nodes. And it can, because we need this to be a zero downtime, it has to only perform on one node at a time so that other 2 nodes are handling the load and they are still available for any kind of traffic and any kind of things those are happening around GitLab. So we're going to see this is in progress. Other 2 are pending. it won't move to the other node until this is complete. So this will gonna take a little while, but yeah, you got probably the gist what exactly it is doing. All right, so we're just gonna come back. It will gonna upgrade the Sidekick deploy node, one of the node that we had provided. Then it will gonna upgrade Prophet, the Sidekick, the Rails, and it will hot reload Puma, which is the application server that runs on the Rails node. And it also needs to reload a Sidekick, which is the background job processor. And these are additional steps, frankly. I mean, this one I just added to kind of make sure on the installed GitLab version, the version that has been installed. And this is another mandatory task. Like I said, whenever you are doing an upgrade of GitLab, for every particular version, there are certain database migration tasks which are compatible or corresponding to that version. Those need to be performed and those have to finish before you could go to the next version. Because there are maybe certain tables would have been dropped or certain new fields, those got introduced, certain new features. So the corresponding version and the underlying database, those need to be in sync with that specific version. For that step, this particular thing is really important to execute the run post database migrations before you could go to the next version. So while this is running, let's just go to our GitLab site and see why, I mean, our GitLab is up or how that is performing, right? So we're going to go and, I mean, part of this demo, we're just going to make some minor kind of tweaks and tricks. I mean, just going to create some random steps. So, all right. So the site is still up, the upgrade is running, and we're just going to go and make certain commits and see. So welcome to, all right. Okay, you can see the site is up while the upgrade is running, and still we can perform the like commits, we can create branches, we can execute our pipelines and all those kind of things. So it is still at this step where, and yeah, so it has completed on the Gitali node and it has moved to the next one. Like I said, and still pending on the third node because it has to keep our GitLab system up and running and functioning. So that way, with the rate control feature, we are able to achieve that piece so that it goes through each individual node of that cluster, perform the upgrade, and then move to the next one. So, okay, now while that is running, we can go into this guy and yeah, come to this. So why zero downtime upgrade? Why there is a need for zero downtime upgrade? So mission critical business applications that use GitLab to perform their lifecycle management, it is a critical component, right? Like, because think it from the point where we saw GitLab being in picture from the project planning, from the idea to production. So there are various teams which are dependent on GitLab for their day-to-day activities, from project planning to the deployment to production, right? So GitLab being a critical component, definitely teams cannot afford major downtimes during the upgrade. So when you are performing an upgrade, definitely there is a downtime that comes in the traditional approach. So if for these mission critical applications to have your GitLab up and running, that is really a key to have your business up and running. And industries like airline industry, the banking system, hospitals, or the life science, you can see, I mean, those are really mission critical applications which cannot afford major downtimes. Teams are dependent on GitLab being highly available. They expect GitLab is up and running so that they can perform, let's say, if in the live application, some bug has introduced, right? And you need to provide a fix. And if you are doing a traditional GitLab upgrade during that time, your GitLab is down, right? You are now dependent. I mean, you won't be able to perform that patch, or you won't be able to perform all the necessary tasks. Those are required to get that addressed quickly. For that, if you're using this, you'll be able to perform that fix because your site is up. All the dependent teams, they can also do their job while your GitLab is up without impacting anybody. And with zero downtime upgrade, it allows you to perform frequent upgrades to keep up with the latest versions. I'm sure most of you may be aware that GitLab releases versions every month, right? Think it from the point. I mean, by the time, let's say you're on 15 or you're on 16.6, which is the latest version, right? Next month, GitLab will be releasing 16.7, right? It gets really difficult, or maybe to keep up with the versions, right? If you're following a traditional approach where you are managing the downtimes, coordinating with various different teams and getting that downtime planned for a weekend, or your operations team need to perform those overnight tasks and those kind of things, it gets challenging, right? So especially during holiday seasons and such, right? So when they need their systems up. So during these, it gets really challenging for the operations team to keep up with the upgraded versions, and you will be left behind onto older versions sometimes at really major organizations. So with this zero downtime upgrade, you can perform frequent upgrades. Okay, you are on 16.6. Next month, let's say GitLab releases 16.7. You can go to 16.7 as soon as that is released, right? So that way you're getting the latest and greatest features. Those are coming up with the latest versions. And the good benefit is it's all automated. So this is less error prone, and it's also cost efficient approach, because this is performing the upgrade performing the upgrade on site. I mean, you can definitely achieve some of the other things using like blue-green setup and those kind of things, but yeah, definitely those will come with cost as well, right? So in this case, like, you can have this and on a cost efficient approach, and it's all automated, so you can test your upgrades before and dev QA and go through the same cycle, but it will be less error prone. I mean, we have used this process, and you could easily perform this in production and without impacting anybody. So yeah, I mean, while this is running, I'll go on this one. Like, definitely there are certain kind of requirements those have to meet for this zero downtime upgrade to work. So I'm gonna kind of cover this. So you can only upgrade one minor release at a time. So let's say you're on 16.2 version, like we saw, which our current site, which was on 16.2, we can go only to 16.3. You cannot go to 16.4 directly, because of the fact, like I said, every version requires its database. There are certain database migration tasks which are corresponding to that version. Those need to be performed before you can go to the next version. So that's a limitation from GitLab end, frankly. So the GitLab zero downtime upgrade process, it only supports one minor or major version at a time. I mean, you can definitely go from, let's say you're on 15.10, which is the latest version in 15 series. You can certainly go to 16.1. So that is supported with zero downtime. So it's not like you cannot switch major versions. You can, but you can only go one version at a time. So from 15.10, you can come to 16.1, but you cannot go to 16.2 directly. So I think still that is a really, I mean, that's a limitation, but that is, I think, well valid. I mean, you can still manage to keep up with your versions, and you can still perform frequent upgrades to get to the latest version always. You have to use post deployment migrations. Yes, we are using that. Yes, definitely. So and you have to make sure the post deployment migrations for that particular version are complete, the upgraded version, before you could move to the next. So let's say in this current setup, as we're going to see to that one once the upgrade is complete. So there are post migration tasks. Okay, so Gitali has been upgraded. This is good. Let's just go back to this guy. All right, so yeah, as you could see, it has successfully upgraded Gitali, the Sidekick deploy node that has been upgraded too. It has moved to the Prophet now. So it will gonna perform all these tasks. I would say maybe another 10-15 minutes, and we'll see our current site that we have been using from 16 to 8. It has moved to 16.3, or how does it look like? So in this case, yeah, I mean, the post deployment migrations for that particular version has to finish. So in this case, like, we are going from 16.2 to 16.3, the post database migration task for 16.3 has to finish before you could go to 16.4. It doesn't take long, but maybe an hour or so, or depending upon your data size, how big your instance is, it could take a little while. But those tasks don't really impact your system. Those run in the backend. Your GitLab site will still be up and running and functioning. So there is no impact at all. You make sure you're using Postgres. Starting from GitLab 12.1, MySQL is not supported. So if you're using MySQL as your database, then you won't be able to use zero downtime upgrade. This approach really requires Postgres as your database only. So that is only supported. You have set up a multi-node GitLab instance. Cloud native hybrid installations do not support zero downtime upgrade. So we saw various different installation methods. One was like omnibus GitLab. So for this to work, you definitely need a multi-node setup. If you just have one node, definitely you won't be able to achieve zero downtime, right? Because if that one node is going through the upgrade, it will gonna bring your site down. So you can only go through this zero downtime upgrade when you have a multi-node site. You have the recommended reference architecture from GitLab, where you have minimum 3 nodes for every or each of those components, like Rails, Sidekick, your Gitali, Prophet. All of these components have minimum 3 nodes for the data redundancy, and to make sure while one node is performing the upgrade, the other is available for your to handle the request or to perform the function. And cloud native hybrid installations. So we did saw you can install GitLab on a Kubernetes environment where you could have Some of these components run on Kubernetes. Though one thing to note, Gitali cluster, which is the key component or the GitLab provided and recommended fault tolerant solution for Git repositories, you cannot deploy Gitali cluster onto Kubernetes. That is not supported by GitLab. So for cloud native hybrid installations, you won't be able to use zero-downtime upgrade. You can only use this when you're using the mature and most recommended and scaled approach, which is the Linux package. You're using the omnibus Linux package. So that's when you can use this guy. Yeah, so let's come back to site. And yeah, this is the flow. And one thing I would like to point out, let's say if you, I mean, this webinar has been designed around GitLab that is hosted in AWS, but it doesn't mean, let's say you have a GitLab site that is hosted in your on-prem or some different systems, still you can achieve zero downtime. For the purpose of this demo, I have used SSM, which is a systems manager feature of AWS, to automate my tasks around zero downtime upgrade. But you can certainly do this exact same thing using Ansible or any other configuration management tool or some other tools that you're using. You can achieve the same thing using different approach. So you can maybe write a shell script, you can write Ansible, you can write, if you're on AWS, then yeah, SSM is so handy and it's so good to use. So let's just look at our upgrade, how that is moving so far. So it's gonna refresh. All right, so it's upgrading Prophet so far, which is the transaction and manager for your Gitali cluster. So one of the node has been upgraded. Let's just go to our site and play around this to make sure our site is still accessible. Okay, good things. Our site is still up. Let's just create a branch. We'll just gonna do some webinar live. Create branch. Okay, all good so far. So it's gonna update this guy. While this is running, making this commit, let's just see. Sorry, I wanna. I'm just gonna open up and look at if you have any kind of questions. Yeah, please feel free to post. I'm just gonna take a little pause here, but yeah, please feel free to post your questions in the Q&A section. And yeah, we have experts who can definitely help answer. And if there is any way we could provide any additional information, the things that you wanna cover, that will be really great. So yeah, we can probably talk about some of the other stuff. But yeah, you can see my upgrade is still running like we had planned, the live upgrade, and site is up. So that is a good thing. And okay, let's just go back. Okay, it has upgraded the other Prophet component and this. So there are, I mean, if you're using AWS, then yeah, it makes little bit easier. I mean, if you're around SSM, there are certain kind of things which have been made around this. There is output limit of like 48K characters only. So the output is sometimes get bigger. You can definitely integrate this with CloudWatch logs and those kind of things in AWS so that your logs are stored and you can still access your logs and go backtrack whenever you have performed the upgrade and you want to look at those logs. You can definitely do that as well. That is a feature of SSM. But yeah, so that has been done as well here, but you'll be able to see the things that have been performed. Let's just look at one thing I would like to point out. So if you go to like GitLab and go to admin, yeah, Gitali server, yes, you could see it's on 16.3.6. So Gitali cluster upgrade has already finished and you could see it's on 16.3.6. But so far you could see the up to date is like a grayed out. It's not green. The reason being Prophet has not been upgraded and the dependent components like Rails and Sidekick, those have not been upgraded. So you're seeing this little gray option. But as soon as all the rest of the components are upgraded to this version, you'll see a little kind of green check mark here. So far, everything is looking good. So yeah, the site is up. In this case, one thing I missed to kind of mention, but I have created this site using GitLab Environment Toolkit in AWS. But yeah, you could see, I mean, definitely this is not production ready because I did not attach a SSL certificate and I don't have a friendly user domain name. But those are the only two things which you would require if you're looking to use GitLab Environment Toolkit and deploy your GitLab into production. So if you're hosting this in production, definitely make sure you are securing this with a SSL certificate to your load balancer. And also, yeah, I'm sure you will need a friendly domain name on which you would like to have your GitLab up and running. But for the purpose of the demo, I'm just using a GitLab load balancer to kind of hit my GitLab instance here. I don't have a domain registered for this demo, but yeah, I mean, it's doing the job. So I think we're good here. Okay. And also one thing that I would like to mention, it will gonna probably take like 30 seconds to 1 minute of an outage. The only reason being when it would perform a hot reload of Puma. I just have 2 nodes of application server, like Rails node here in this case. But in real production, when you will be doing this job, you can definitely remove that. Okay, let's say 30 seconds or 1 minute. If that is also too much and you cannot afford that downtime, you can certainly make it 100% zero downtime as well. You just need to remove your Rails node from the load balancer, do the restart, reattach back that node onto the load balancer. That's how you can achieve it. But for the purpose of this demo, I didn't add that additional step because I think we are okay with 30 seconds to 1 minute of an outage when it's doing a reload of Puma. So, but yeah, other than that, I think it should be all kind of smooth and it should just perform the upgrade here. So now that we got a little bit of time, I can cover some of the step around the GitLab environment toolkit, how this site was created, and how if you would like to kind of play around with GitLab or you want to host your site or mess around systems, then definitely you can kind of use the GitLab environment toolkit. So if you go to this guy and just type in GitLab environment toolkit, the first project that you see, this is the project that has been used. It's an open source project developed by the GitLab engineering team and very well maintained and supported. It uses Terraform and Ansible scripts. So you would definitely require knowledge around those tooling to kind of make, I mean, the readmes and the guide is pretty self-explanatory. So you would be able to still kind of make good use of it. There are certain kind of configurations that you would require to mess around to make this work. I see some Q&A, so let me. Yeah, I mean, we did. Yes, we can certainly push the GitLab repos as well while the zero downtime upgrade is running. Yes, Tosin, that is still that can still be done. So I mean, I did a local commits here, but yeah, you can certainly like perform any kind of push, pull, and those kind of things that will also gonna work here. So. Let's see. I mean, I've been making commits from here, but yeah, feel free to kind of, you can certainly do like, let's see, I mean, oh, I don't have the, one second. Oh yeah, awesome. It worked. I was like, I remember the password for root. Yep. So yeah, you can see, you can certainly do push, pull, any kind of things while the upgrade is running. So if you do this guy. Yep. So now you can see, let's come back here. Just refresh this guy. Yes, CLI. So all the kind of basic functioning, including your pipelines. I mean, for the purpose of this demo, when I do have installed a GitLab runner. If you're not familiar with runners are exactly similar to like your Jenkins agents, which would perform basically, which would execute your pipeline jobs and such. So that's how it works. So let's just go
to that point. We have a question. Will there be any issues with agent connectivity?
No, yeah. So while the upgrade is running, all of your builds, those will still perform the job, and you won't see any sort of timeouts or something. There would be only in the case when that hot reload Puma is working in my current site, at least, because I did not make like detach the load node from the load balancer, restart, and then reattach back, right? That's the only case. If sometimes I have seen where you may need to rerun your pipeline. So that is the only thing. But other than that, most of the time your pipelines will be good, only except the fact when it is at this step where it's this guy, hot reload of Puma. When it's at this step, there is a possibility your pipeline may not finish and you may just need to rerun. But yeah, rerun would work perfectly fine. So that would still not be at an issue at all. So you may need to just rerun a pipeline if it gets failed at this step. But I mean, that's very rare, frankly. I haven't seen that issue. I mean, we did perform these upgrades in production site, like 6 upgrades we haven't performed so far using this approach in the production, and we did not face any issues at all. But yeah, that is the only thing you may see a little kind of discrepancy, but yeah, rerun of the pipeline would work. Okay, so while it's at the Rails step, I think, yeah, most likely we should still be able to make it on time, but yeah, let's see. So while that is running, we just saw like we are able to make the commits, our pipelines are running, and all the kind of things are looking good here so far. So we're just gonna go and cover few things on the GitLab Environment Toolkit project. So this is the GitLab Environment Toolkit project, and there is a little guide. If you just scroll down here, quick start guide, preparing the environment, provisioning the environment with Terraform. So on the quick start guide, you will see it requires certain kind of things around like you're definitely, if you're using AWS, you'll need AWS region, your access key ID, secret access key, and those kind of things. You definitely require a SSH key that will be used to communicate with your EC2 instances. Those have been launched, and those kind of things. You'll definitely need a Terraform and Ansible installed on your local. We're going to create one environment inventory using this, and simply using Terraform init and Terraform apply, it will going to create all the infrastructure that is required for your GitLab to be up and running. And you're defining those configurations here. So this environment.tf that you see here, you are defining the AMI that needs to be used by your instances. Those are getting launched. The every node count, the instance type, and all the rest of the configuration. There are certain additional things those are required here. I mean, this is just like US East 2, which is the region. You need to specify which region you are using. Bucket. So there is one additional requirement. You need this bucket to be created beforehand. Your automation expects this bucket to keep your Terraform state files in that particular S3 bucket. In the variables.tf, you would see, I mean, frankly, this external IP allocation, I was able to get rid of this. You don't really require that if you're using an internet-facing load balancer. You can use the internet-facing load balancer, and if your instances are hosted in a public subnet, you don't really require this guy. So you can come out of this guy, come out of this config. Some of these configs, the passwords that you want to, I mean, for the purpose of demo, I mean, I kept it really simple, but yeah, those are the things. And as soon as you apply the Terraform apply, it will going to create all of the EC2 instances, your RDS, your VPC if you specify, and load balancer, which will get created with this little config. So ELB internal create. So this particular config creates the load balancer. And the output of this Terraform apply, once your instances are created, you will need those output to be passed to Ansible. So now your infrastructure is ready, but on that infrastructure using this Ansible code, we will gonna install, I mean, this will gonna install GitLab. You can specify the version that you want. You can specify some of the additional any sort of configurations that you require around GitLab. You can define those things, but there are certain things that is really required is the user that will be used to connect to your EC2 instances, the region, the prefix for the environment. Like in this case, I just used Zero-downtime here. External URL. This is the URL of the load balancer that got created from the Terraform. This is the Postgres database host. I mean the endpoint URL. And this is the Prophet RDS instance that got created through that Terraform. So these are some of the configs that you would need to update. Similarly for Redis and Redis persistent. Internal load balancer is same as external URL. In the case, let's say, I mean, for the purpose of this demo, I did not create a separate Route 53 domain or a friendly URL. But if you have a, let's say, friendly domain called gitlab.adaptavist.com, for example, this external URL would change to that friendly domain in that case. But other than that, it should be pretty much same. some of the passwords and those kind of things. I don't use this one. This is I'm just using it for the demo purpose. But yeah, I think that is kind of all. And you just apply. There is a all.yaml. Basically, it will gonna call all of your. If you go to Ansible here and roles, you will see there is a all.yaml playbook. So, okay, one second. Sorry, inside playbooks, if you go and there is a this file. So basically, this all.yaml, when you apply, you'll simply just gonna run Ansible playbook all.yaml, and it will gonna execute all of these playbooks. And in a under the hood, these playbooks are calling the corresponding roles for each of these individual components and setting up and configuring those individual pieces to make your GitLab up and running. On roughly, I would say it took like 45 minutes. It would take like for Terraform to deploy like 20-25 minutes and Ansible to run. So in less than an hour, you can make your GitLab up and running in the environment. The multi-node, highly scalable solution of GitLab up and running using this. Now let's just go quickly over the automation that has been built. So zero downtime upgrade automation. What exactly it is doing under the hood, right? So this is the SSM automation. And like I said, if you are not hosting your GitLab onto AWS, you can certainly design this sort of automation using Ansible, using shell script or any other things. But if you're on AWS, SSM makes it much easier and simpler to perform the upgrades and do the task for you. So this is the automation that I have built. So in this case, I'm just specifying a role, the IAM role that will be created with all of the permissions. Those are necessary to perform the SSM tasks onto the corresponding nodes, which will be used. In this case, certain parameters that we got as an input. One is GitLab upgrade version, the version of GitLab that you want to get upgraded to. Default is 6 to 16.2.8, but yeah, you can change to 16.3.6 or any of those values. But yeah, you would need to use this guide to come up with the version that you want to use. So let's say you're on 16.1.5 and 16.6.2 is the latest. Make sure you tick zero downtime, because if you remove this flag, the upgrade path will be different. So, but for zero downtime, there is a specific upgrade path that you will need to go through, right? So you can go from 16.1 to 16.2.8, 16.3.6, 16.4.4, 5.4, and 6.2. So that's how you're gonna incrementally upgrade your instance every time the new GitLab version is up. I mean, frankly, using this approach, I think you can perform 2 to 3, at the minimum 3 times upgrade in a week. So, I mean, you can create an automated flow with which you are performing the upgrade and testing that in dev and QA and going to the production. But yeah, I think for the post database migrations, yeah, that is one key component that you will need to make sure that your post database migrations for that version, specific to that version, those are complete before you could go to the next version. So that is the only kind of key before that you have to kind of keep in mind. But other than that, yeah, these are the versions that you will go through and you can perform these upgrades. So let's just look at our SSM automation. How does that look like so far? Oh, awesome. That was quick.
So Gopal, you touched on this a little bit before. Sorry to interrupt, but can you elaborate a little bit more on how and why the amount of data may affect the upgrade time?
Yes, sure. Yeah, let's just look at this upgrade guide, and yeah, I can cover how that can really impact the timeline on the upgrade side. So our SSM automation is all complete. Let's just come back to our site, and we would love to see this on 16.3.6. So let's just go to this guy. You can check there are various ways with which you could check the GitLab version. If you just type in /help at the top of your GitLab URL, yes, it's on 16.3.6. So, I mean, thanks to the DevOps gods, I mean, the upgrade worked like we planned, the live upgrade. So that's good. Okay, so if you go to admin, go to Gitali servers, yeah, you can see the up-to-date, it's green. So that's a good sign, because earlier, like you guys saw, that was on a gray section because the dependent components like Rails, Sidekick, Prophet, those have not been upgraded to 16.3.6 by then. The very first upgrade of Gitali that was complete. So this was showing earlier as well, but this was grayed out. But now that is green. That means all the components and the way Gitali interacts with the dependent components. So that's all the connection, and that is also working well. So it's all good. If you come to dashboard, here also you can check the version. So if you just scroll down, you can see, yes, GitLab is on 16.3.6. So we successfully upgraded from the version 16.2.8 to 16.3.6 with the zero downtime. So yeah, and now coming to the one key component that would matter. Yeah. So like I was mentioning, there are certain background migrations, those need to finish before you could go to the next version, right? And you can look at those background migrations from admin in monitoring background migrations. So come to this guy, this task, you can see all the, there are no queued and finalizing and failed, all finished. So there are 13 background migrations and those of all are complete. So this makes it clean for you to upgrade to the next version. So you're all good. You can go to the next version, which is 16.4.4. So you can perform the upgrade to 16.4.4 as well. Everything will just work fine because, but yeah, in certain scenarios, and coming back to your question, Carl, so in certain scenario, let's say, imagine you have huge amount of repository and you have like 500 GB of underlying Git repository storage, similarly your database storage, and you have a huge site. When it performs it's similar to if you're familiar with Jira reindexing and those kind of things, right? So it's similar to those kind of things where the background migrations that can really impact the underlying system or underlying data as well. So it could take a little while if your data size is big, but in certain scenario, this was really quick because frankly, I don't have much data. I just have like 3 different projects and those are all like dummy projects. But in real production site, this may take like 1 to 2 hours, but not more than that. Since I have experience with like 500 to 700 gigs of data, and yeah, it did not take more than 2 hours. So yeah, but definitely if you have like 1000 gigs or more than that, this would be a little thing that could take a little while to go through all of those records, underlying things, and perform those migrations for it. But and yeah, one good thing is while those background migrations are running, your site will not be impacted at all. And none of the functionality, including your GitLab pipelines or any sort of the things, those will not be impacted at all while those background migrations are running. So your site will still be functional, everything will be good, and you can still perform this thing. Coming
Gopal,
to
quick time check. We only have a couple of minutes left. And there's one thing I want to draw your attention to. Carl sort of already responded to that. What is a restore recovery process in case if the upgrade goes wrong?
That's a very good question. Yes. So in the case, let's say if the things don't go as per your plan, in this case, because it's a upgrade in place, definitely we would need to take the Gitali, which is so in the case of GitLab, only 3 things that matter. So you need to take the backup of your databases, both the databases, like your GitLab database, your Prophet database, and the component is Gitali. So you need to take the backup of Gitali because Gitali is the one which holds all of your Git repositories. So you will need to perform a restore to using those snapshots that you took before the automation. We can simply, in the real world, frankly, you can have a SSM automation first step rather than directly going through the upgrade. You can add a simple task which will create the backups for you for your Gitali and for both your databases. So that can be achieved if you have stuff hosted in AWS. And once you have backups, yes, the restore process will be, you will need to restore using those snapshots into the corresponding, in the same region, a different site will need to be created. It will be like a blue-green scenario in this case, because you are performing this upgrade with zero downtime on in place. You can still rely upon your geo site if you're using GitLab geo feature, which is a for the distributed teams. You can have like reads, those get simplified, and also that can be used for disaster recovery as well. You can rely upon your GitLab geo node to get picked up as a primary site if anything goes wrong in this case. So that can be used as well. I hope that answers. But yeah, any other?
Thank you. I think that's it, and that's about time for us.
Yeah, yeah, thank you so much, guys. I'm really glad the upgrade worked as planned, and yeah, we are able to perform the live upgrade. And yeah, everything is looking good. So health check is also coming up good, and yeah, we are on 16.3.8 now, so that's a good thing. But yeah, and thank you for joining. I hope you learned something new or something interesting fact. But yeah, if there are any other kind of things that you would like to, if you have any questions around this, or if you think maybe later when you go through the recording, definitely please reach out to us. You can definitely come through Vanessa, or you can ping any one of us. You have our emails. Yeah, it would be really great. We'll be more than happy to assist with any sort of things around GitLab. And yeah, thank you. Thank you for joining.
Thank you. Thank you, guys.
Thanks all.
Yeah.
Thank you.